Welcome to App 305, Migrate and Modernize with Amazon EKS. In this session, you'll hear about reasons why people modernize their on-premises workload with Kubernetes and how you can migrate those workloads to the cloud with Amazon EKS. We'll cover some of the benefits that Amazon EKS can bring, and also some common issues that EKS and Carpenter can help you solve. We're joined on stage today by Experian, who are going to tell us about their journey in modernizing their workloads with Amazon EKS, EKS Anywhere, and Carpenter. My name's Liz Duke, and I'm a Principal Specialist SA for Containers at AWS.
My name is Mikhail Stoyanov, and I'm a Senior Technical Account Manager with AWS.
Hi, my name is Ruben. I'm a Lead Platform Architect at Experian.
So we talk a lot about modernizing applications and workloads, but why modernize? Well, if you think of your application as a car, and yours looks something like this, then I think you can tell it would take quite a lot of work and effort to add new features to make this appeal to your customers. Similar to the way that with monolithic applications, it takes a lot of time and effort to add new features, so maybe you're not innovating as quickly as you'd like to be. Now, that doesn't mean that every monolith has to be modernized. Maybe your application is feature complete and only requires very few updates, a classic, if you will. But for those that aren't and who want to modernize using Kubernetes, there are decisions to be made. So there are many ways to modernize applications and workloads, but a very popular choice is Kubernetes. And there are several reasons for that. The move to breaking down monoliths into loosely coupled containers as a lightweight and portable way to run complex applications has become the preferred way for many organizations to support complex application architectures for flexible infrastructure, rapid deployment, and continuous innovation that can run anywhere. Kubernetes is declarative. What that means is you tell it how you want your application deployed and how you want it to scale, and Kubernetes will reconcile to achieve that. Kubernetes also has a consistent API. As long as your distribution of Kubernetes is upstream Kubernetes conformant, spoiler alert, Amazon EKS is upstream Kubernetes conformant, then you get to use the same API whether you're running your applications on premises or in the cloud, which makes it really portable. Kubernetes has a strong and rich ecosystem. You only have to look at the CNCF cloud map to see the amount of choices that you gain from that. And whilst Kubernetes is open source, it has a really strong community with a lot of enterprises helping drive the direction and actively committing to Kubernetes. And again, you get to take advantage of that. So, as you're sitting in this session, you've probably decided that Kubernetes is the way. And if we think about starting with your on-premises workloads, what are the options that you have with Amazon EKS? Well, if you want to extend your VPC to on-premises, so you could use Amazon EKS on AWS Outpost Rack Server. With Rack Server, you can either use the shared control plane in the cloud, or you can localize the control plane within the rack itself. And this probably suits those customers who have a strong requirement for their applications to run really close to a certain physical location, like in a manufacturing plant, for example. And especially if they don't have maybe pre-existing hardware. But what about if you need to run Kubernetes in an air-gapped environment, maybe for regulatory reasons? Or you want to run Kubernetes on a moving target. I'm talking planes, trains, and automobiles here. And yes, we do get asked if we can run EKS on planes and trains and automobiles. So if that is your situation, then maybe you should look at Amazon EKS Anywhere. You get the same distribution of Kubernetes as we run in EKS, but you run both the control plane and the data plane yourself on your hardware with some support and tooling from AWS. But how about if your workloads don't fit into those cases? So we had a lot of customers who said that they already had a lot of pre-existing hardware that they wanted to make the best use of on premises. They had some workloads that were destined to stay on premises permanently, with others that they wanted to move to the cloud eventually. And they wanted a consistent experience between their on-premises Kubernetes and their cloud Kubernetes, and they didn't want to spend a lot of time in managing Kubernetes itself. For those customers and those use cases at reInvent 2024, we introduced Amazon EKS hybrid nodes. So why hybrid nodes? Why not just run your own distribution of Kubernetes? You could even run EKS distro. Again, that's free, it's open source, it's the same distribution we run in EKS. But when you're doing that, you've got to take on the responsibility for running your control plane yourself. And it's not only about deploying the control plane. Running a Kubernetes control plane is not a core skill for most businesses. When you run your own Kubernetes control plane, you have to deploy it, you have to scale it, you have to make it resilient, and you have to secure it. So this all takes time and resources, both people and infrastructure. And that is better spent on modernizing or running your own applications and adding new features. So with hybrid nodes, you get the benefit of using the shared EKS control plane. So let's look at those challenges and the benefits that control plane brings. The EKS control plane is fully managed and resilient. We run 2 copies of the API server and 3 copies of etcd, the Kubernetes state store, in an AWS managed account across multiple availability zones. And you get support with your EKS control plane 24 hours a day, 365 days a year. When you're upgrading the EKS control plane, that's just a single action, whether it's through the API, the CLI, or through the console. So what about security? Well, the EKS control plane, the nodes that we select for the control plane are all hybrid, are all Nitro instances that support encryption in transit. We also, by default, encrypt the block stores that we use for etcd as well. So now you have encryption both in transit and at rest within your control plane. And in March this year, we released default object encryption for etcd. What that means is that every object that is stored in etcd is encrypted with a KMS key. Now you can either just choose to leave it up to us and use an AWS owned key for that encryption, or if you prefer, you can bring your own KMS key and use that to do the encryption instead. So that's security ticked off in those challenges. But what about when you're scaling your cluster? When you scale your pods and nodes, EKS takes care of scaling the control plane for you behind the scenes. And as we learned how the control plane behaved under different conditions, we changed the metrics that we looked at to make that scaling more responsive. Today we use a variety of metrics, including the number of nodes and the size of the etcd database to scale the control plane and make it more rapid scaling. And also, once we've scaled up the control plane, we don't scale it back down again unless your utilization has dropped below that scaling threshold and remained there for several days. So what does hybrid nodes look like from an architecture perspective? Well, we'll start off with that shared cluster control plane, right? Because that's one of the big benefits there. That cluster control plane should be created in the region that's closest to your on-premises architecture. Now, while it might be fun to think of spinning up the control plane in Sydney while your servers are in Southampton, you're probably not going to get the best round-trip response from your network connection there. You get to keep your on-premises infrastructure, and now you only use that on-premises infrastructure to run your applications, not the control plane. And those on-premises nodes, they can be physical, they can be virtual, they can be x86, or they can be ARM. You also need to have a redundant network connection between your control plane and your data plane. Now, this needs to be performant, so you need to have good bandwidth for that connection, and we recommend either using a site-to-site VPN, so your own or an AWS one, or using Direct Connect to make sure you've got that good, consistent network connection between the cloud and your on-premises nodes. You get to use the same APIs with hybrid nodes that you're used to if you're already running EKS. But also, in addition to that, you can integrate easily other AWS services. So things like Amazon CloudWatch for observability, Amazon Guard Duty for monitoring your Kubernetes audit logs, and AWS Identity and Access Management, both for authenticating your nodes into the cluster using IAM roles anywhere or Systems Manager hybrid activations, but also for authenticating users into the cluster using Cluster Access Management. Now, some of you sitting here might be thinking, that's all very well, but what about the elephant in the room? And now other people are sitting there thinking, there's an elephant in the room? Meet the elephant in the room. So this is about the timeout between the Kubernetes control plane and the data plane limits. So what happens if that network connection, and remember you've got redundant network connections here, if both those connections are cut and your control plane can't talk to your data plane? In Kubernetes, in the control plane, the node controller, if it can't reach a node, will set the status of that node to unknown. After 5 minutes, it will attempt to force a pod eviction of all pods on that node. Guess what? If it can't reach the node, it can't evict the pods, so everything just keeps running. And in fact, if anything running on the node itself falls over, the kubelet on that node tries to repair it. Now, one of our customers decided to test this out when they were doing the beta testing of hybrid nodes for us. So they cut all connectivity between the data plane and the control plane. They didn't do that for 5 minutes. They didn't do it for 5 hours. No, they did it for 5 days. They disabled it on Monday and didn't re-enable it again until Friday. In their words, everything just worked. So if you can tolerate a static configuration whilst you've got this network disconnection, and by that I mean you're not constantly mutating your configuration of your applications on the nodes, then Amazon EKS hybrid nodes could be a solution for you. We actually documented a lot of the various different disconnection types and different scenarios, and we've put all that information and what you should do in those cases into the hybrid nodes best practices guide, which we'll link you to at the end of this presentation. What if you could have a cluster that was split across the cloud and on premises? You get to use your existing infrastructure, migrate when you need to, and as a bonus you get to use the same control plane in the cloud. Now, when you're ready, you can migrate the pods by changing the affinity of those pods, and they will start migrating to the nodes in AWS. Now, this is only showing you migrating the nodes. Obviously, there are other things to take into consideration here. Things like data store. If you're using that data store on premises, how do you migrate that to AWS as well? But what about load balancing across your workloads? With hybrid nodes, you can actually use in mixed mode clusters both an application load balancer or a network load balancer to load balance the traffic both across your workloads in the cloud and your on-premises workloads as well. What other scenarios could hybrid nodes be of use for? Maybe your application has fairly consistent traffic, but a few times a year you get a huge spike in usage. You don't want to maintain infrastructure solely for that, to keep that standing by in your data center, make sure it's up to date. That would be expensive and not as much use. So you could use it as an option to burst to the cloud. Another option for hybrid nodes is to think of it as a disaster recovery solution for your on-premises infrastructure. If something catastrophic happens within your data center, then you could fail over to running that workload in the cloud. Now, these again are all scenarios that our customers have tested out for us using hybrid nodes. So now we've looked at the on-premises options and migration with EKS and the benefits of using a shared control plane. What about running EKS in the cloud? For that, I'm going to hand you over to Mihail.
Thank you, Liz. As a technical account manager at AWS, working with enterprise customers, I consistently see three challenges they are facing with Kubernetes. The first one is about maintaining high availability and resiliency for their business critical workloads. The second one is managing the scalability complexity. And the third one is optimizing for costs. Today I'll show you how Amazon EKS and Carpenter can help you with these. But before we start, let's talk about the foundational infrastructure. At Amazon, we take resiliency very seriously. This is a cornerstone of the modern cloud architecture, and in fact, it is one of the foundational pillars of the well-architected frameworks. With that in mind, AWS builds its own regions based on these principles. There are 36 regions globally, which are not just arbitrary separations. They're rather isolated from each other, running independently, each of which containing 3 or more availability zones. Each availability zone connects to a transit node that provides high bandwidth, low latency networking for business critical applications. A common misconception is that an availability zone is consisting of a single data center. In reality, an availability zone can be consisting of more than one data center, which is there for business continuity, especially when there are localized failures. This multi-layered approach, as you can see, is very important it's really crucial for maintaining high availability and disaster recovery. Now, EKS is leveraging already that on the control plane, as you heard from Liz, but how you can leverage it for your own applications. On the diagram, you see that there are 3 availability zones, and let's imagine there are 3 EKS nodes. A common anti-pattern we see is where customers are putting all their pots on a single node. If you're familiar with the expression of put all the eggs in one basket, well, you don't want to do this. What you want to do is, once you have your pod running, is spread around for high availability and resiliency. And I will show you how this is made very easy with Carpenter and with the node put example that you see on the screen. But before that, let's first talk about Kubernetes scheduling requirements. AWS customers often need to define different rules of how they're placing their pods. For example, they might require certain use of certain specialized instances for GPU or Graviton, which is helping with savings, or, well, on the savings topic, spot instances. Or they might have certain compliance or regulatory requirements, like, for example, use of dedicated instances or dedicated hosts. Standard Kubernetes offers 4 mechanisms to control your pod placement. The first one is node selectors. It's a very simple mechanism. You can think of this as a key value pair that's where you specify the type of instances you want your workloads to run on. It's very simplistic, but it doesn't offer any level of flexibility, and this is where node affinity comes in, which provides you with an opportunity to define either required or preferred rules for when you want your workload to run on specific hardware or best effort type of placement. Taints and tolerations works the opposite of node affinity. Think of this as rather a way for you to specify where your workload, how you should not work on a specific hardware, like for example, or let's say spot instances. Last but not least, topology spread. This is the one that helps you with ensuring that your workload is running across all the available EKS nodes in different availability zones in the previous example that I showed you. A very powerful thing about this is that you can combine them. So your workload may use multiple of these. And while this is a power, this is also a drawback, which is you need to ensure that your pod scheduling constraints are working within the same configuration. So thorough testing is important for different scenarios. Now that we talked about this, let's talk about scaling and rather Kubernetes scaling of pods. There are also 4 mechanisms for that. Horizontal pod autoscaler is very powerful and says exactly what it is on the tint. It will add more nodes to your workloads as the CPU utilization increases and also reduce the number of pods as the utilization drops. This is very useful when you have a web application with very predictable CPU consumption. Now, vertical pod autoscaler is there to help you with something very different. Let's say you have a Java application where the consumption of memory initially is at 2 gigabytes, and then as load increases, maybe it needs 3 gigabytes. Vertical pod autoscaler will help you with this, and importantly, you don't need to over-provision your pods beforehand. I will tell you more about the Kubernetes event-driven autoscaler in a bit, but the cluster proportional autoscaler is there to help you when you need to scale the whole cluster proportionally, especially useful with DNS and other shared services as the load increases on your workload. Each of these work independently. They have their own purpose. The important bit here is that you can also combine these, and you could have, for example, horizontal pod autoscaler for day-to-day scaling, and you can use KEDA or the Kubernetes event-driven autoscaler for more specific, let's say, batch job type of subset in your workload. Talking about Kubernetes event-driven autoscaler, as you could see here on this complex diagram, it does work with the horizontal pod autoscaler. And you might be asking yourself, well, wait a minute, the horizontal pod autoscaler, shouldn't be using that instead? So important differentiation here is that the horizontal pod autoscaler uses metrics that are coming from inside your cluster, like CPU or memory, or custom metrics that you have. But what if you have metrics that are outside of the cluster? Let's say that you have a DynamoDB query from which you need to process certain amount of items, or perhaps you do have an event queue that you want to process and you want to introduce more processing nodes, so you could work through that queue more quickly. This is where KEDA comes in and provides you with an opportunity to define the behavior of and the scalability of your clusters in a much more customized manner, where you deeply understand how your architecture and how your application behaves. And now getting to the carpenter, I would like to tell you how that really revolutionizes the way you scale your infrastructure. But before that, let's talk about how the Kubernetes standard cluster autoscaler works. So as you see on the diagram, first the pod auto scaling is triggered. From there, if there is no hardware to run that pod on, this is being added to a pending pods queue. Then the cluster autoscaler picks this up and it instructs an autoscaling group, an associated autoscaling group, to introduce a new instance which is predefined, and then that's one that instance is healthy and running, that's being added to an EC2 fleet. This usually takes about between 3 and 5 minutes, which might be actually perfectly fine for your workload, but let's say that you need quicker response. And also, what if you want a flexibility about the instances that you're using? Say, for example, you want to use a different instance, mix of instance types. You'd have to define your auto-scaling groups, multiple of these, and hope that you're right. Carpenter simplifies this by directly detecting the pending pods. And from there, based on the node pool configurations, which actually extend on the Kubernetes one, so these are built upon the Kubernetes standard node pools, but extend them further, and based on the EC2 node class rules that you defined, it will directly talk to the EC2 Fleet API and provision the needed hardware for your pods. An important note here is this is not just about speed, as you can guess with this approach and talking directly with the API and not having to scale for the auto-scaling group to do that for it. It can do first the usual response is up to 60 seconds. But the other important bit is that it can use the whole variety of instance types that are there. And you don't have to manage that. You could actually use the scheduling constraints that I showed you earlier to define what type of hardware it cannot run on or the specific requirements that you have. This adds a level of flexibility, but it also helps with operations burden, reducing the time you having to manage all this. Another important point is that it can also help with costs. And speaking of costs, according to the FinOps for Kubernetes FinOps Foundation, this is the distribution, as you see on the chart, of the actual cost drivers in a Kubernetes cluster. There is, I want to make a note here that there is a tiny cost for the control plane, but is negligible compared to the other costs. Having working with enterprise customers at AWS, I have noticed that it's a constant struggle to optimize underutilized hardware where the hardware is not fully used as originally intended by architecture. This might be due to scaling constraints or changes in the workload. And this is where Carpenter can help as well. Carpenter offers a consolidation feature, which rather what it actually does is it tracks the utilization of your application in terms of pods on nodes, and what it would do is it would try to remove any underutilized nodes and migrate the pods by draining the existing ones and introducing new pods in the hardware that is already available. Or it will completely redeploy new instances that are more appropriate for your workload. It would learn from your application and apply these over time. This happens automatically without you having to manage this, of course, respecting your rules. This is where testing is important, so you provide the most optimal scenario for Carpenter to work on. And before I wrap up, I want to tell you that Carpenter also helps with operations burden from the perspective of patching and upgrading. So when you're ready to upgrade, you could apply the upgrade to the control plane, and then the drifting feature in Carpenter will use the latest image and apply across your worker nodes. An important note there is that you don't want to end up in a situation where you're running an image that you haven't tested. So version pinning is critical for you to ensure that you have you're actually running images that your teams have tested in lower environments. So we strongly recommend these. And with this, you can have zero-touch upgrades that are both operations burden-free, but also secure with the version that of images that you actually have tested. With this, I would like to hand now to Ruben from Experian to tell us about their story.
Right, yeah. As I said, I'm Ruben. I work for Experian. I'm here to tell you about the journey that we took with AWS and EKS and the Experian did. So first of all, let's start with Experian itself. I'll tell you a bit about Experian. Experian is a company that's well known for its credit reports and credit scores, but we actually host and operate a multitude of B2B applications in the cloud and on-prem. And we help a lot in different industries with fraud and ID for our clients. We help with in the healthcare sector to provide better healthcare, or have our customers provide better healthcare. We also provide digital marketing and other things. Experian has about 22,000 employees, and we operate in 32 different companies. So in a nutshell, Experian is a big data and a technology company. I'm here to talk to you about the Experian Ascent platform. We've written the platform many years ago, and it's mainly EKS based with multiple AWS services today. But this is not where we started. We set out this goal to host a multitude of SaaS offerings to our customers, and those solutions are all Experian-based products. We had a lot of requirements for this, like high scalability, and we wanted to be deployed worldwide in 9 different regions. We needed green, blue deployments. We needed rolling deployments. We needed many more things. We needed hybrid environments. So where did this journey start? This started in development for us, because in development we had a problem that originally we were hosted on our self-hosted Kubernetes. And the problem with self-hosted Kubernetes was that we had one single team that was supporting both our development and our production environments. And if there's issues, yeah, production gets priority, we get that. But that didn't work for us, because that meant that we had delays in development. So actually what we did is we pivoted our Kubernetes self-hosted environment in development, and we pivoted that to EKS. And for us, that meant we had AWS enterprise level support. And that's great, because we have that. For us, it was development, but for AWS, it was production. That meant we had faster development time. We had lower maintenance. We could use AWS tagging and EKS tagging, so that we have custom optimization even in development, and we had clear ownership of which development environment belonged to which team. After our success in development, we had a requirement for one of our products in Experian that they wanted a lower latency environment, because the latency, the environment they were currently using was giving them too high latency. To do that, we actually used our code base that we had produced in development, and we deployed it as a backend in production. And that was great, because we already had experience with that code base from development, and we just deployed the same thing in production. That meant that the application that was hosted then had a low latency environment. And the great thing about all of this is that we deployed this entire solution in about 28 days. So again, enterprise level support for our solution meant that we had a product that we're now confident on. Next, we had a requirement from in a specific region in production where our self-hosted Kubernetes wasn't available. So we again deployed our solution in that region, and it meant that we had we overcame many difficulties to do with networking, latency, cost scaling, and high availability. So additionally, we took the cost optimization we did in development, and we also applied this in production, and that meant that we could count on the same cost optimization that we had in all of our other environments. And then after that, we set a target for ourselves, and we wanted to reduce our costs in our production environments by about 30%. So then it came time to roll out our solution that we built to roll this out in a single from a single code base all the way in production on EKS clusters, and we deployed this globally in 7 different regions. AWS helped us identifying difficulties. They helped us build racing models and other things so that we could identify what the responsibilities were between global and regional teams. Another problem we had was that we didn't really know. We had many problems because we had to upskill our customer teams, our support teams, and our SRE. And so AWS helped us to build skill paths for those engineers. And it also, we also did some gaming days. And that meant that we could roll out our solution worldwide. And we basically rolled out our solution region by region, customer by customer, with like no downtime at all for our customers. Lastly, I want to talk about EKS Anywhere. We have a very client-centric approach, and we have a lot of clients with a lot of different requirements. And one of the problems we had is that some of our clients want their workload to run on-prem in our data centers. And we couldn't do that with EKS Cloud. So we went to Amazon, and they suggested that we look into Amazon Anywhere. And that was a great fit for us because we had that code base already from development, from production, from all our different applications. And we could apply our same code base that we had in development and in production on-prem now with EKS Anywhere. So it served the client's needs. We could run our workloads on premises, but still use our code base that we used for the cloud. Now, we started with development. We had EKS Cloud in development and then in production, and we had EKS Anywhere, and then now we just literally have EKS everywhere. So quickly want to talk about the impact that had for us. So first, supportability. We had a very good pace of supportability. We could just roll out to all of our clients, to all of our environments with the same headcount. Next, we had our flexibility. We so we had the ability to expand and create custom build solutions for our customers. And we lowered our development lifecycle significantly. Next, we had innovation. Means we had we had multi-tenancy in the cloud, but also on-prem. We could build the same solution anywhere, and it means that you don't waste time trying to fit for different environments. Then we had portability. A single code base, as I said many times, we had a single code base both on dev, in prod, and on-prem. That meant that our solution is very portable and can be deployed anywhere. Next, we have resiliency. We could use the existing AWS resiliency and build on top of that. So we had resiliency, we had a starting point of resiliency from AWS, and we could build on top of that. And then cost optimization. This was a big one for us because actually our target was set for 30% reduction in cost, but what we achieved was about 87% in cost, which is significant for us. Lastly, I want to take some time to thank AWS for the ongoing commitment from the AWS teams like Mihail, and for the AWS specialists like Liz that helped us in this journey. Thank you very much. Back to you, Liz.
Thanks. So, what can we take away from this? With hybrid nodes, you get a consistent EKS experience for those workloads that need to stay on premises, but you get to use the managed cluster control plane. This will make your migration journey easier. With Amazon EKS and Carpenter, you can make your EKS workloads resilient easily, you can scale them quickly, and you can also use some of the inbuilt features from Carpenter to cost optimize without a huge additional input from yourselves. So, if you want to learn more, we have free skill builder resources for you to go and do some different training courses. One of those training courses is the Amazon EKS Digital Badge. This is for those who don't know really about EKS and you want to get up to speed with EKS. You can go do the badge, do the learning, and do a set of questions at the end to test you, and as long as you pass, then you will get a badge that you can share from Credly. We also have a link up to the Amazon EKS best practices. If you haven't seen this yet, please go read it. It covers everything from security to resilience to scaling, and also hybrid nodes has its own section in there. With that, I would like to thank you for coming to our talk. Please take the QR code from this and complete the session in the mobile app. We really appreciate your feedback. I hope you enjoyed the talk. Thank you very much.